Okay, so is anybody presenting today? Okay, we have one presenter. Okay, while you're presenting, if uh, somebody like comes into the room, I can't like automatic, so it'll pop up this thing over here. Okay, so you just have to invite them, and then, or I'll do it. I'll be watching. Okay. Okay, so uh, I'll go to the Google Drive, and then we'll start. Okay. Uh, Here we go. Okay, by the way, if I owe anybody any grades, let me know. Um, I think I'm up to date with the grades, but maybe I'm wrong. Okay. So you uploaded it, right? Okay. I'll just bring you to the right folder. And oh, it's hot in here. I don't know why it's so slow. Okay. Here you go.
So, my presentation is about why it might be tempting to place code in a class constructor and why it is typically a bad idea. Um, so just to first kind of talk about, oh, my apologies.
Yeah, that happened to me also.
Just to first kind of talk about what I'm going to be covering today. So first, I'm going to cover kind of briefly what is a constructor, why you might think that it's a good idea to place code in the constructor value, the problem with that, and then the solution to that. So what is a constructor? So a constructor is typically a special method that's used to
Oh, wait, a minute, I'll just click on top of somebody. And then could hide again. Those three dots. Yeah, just no, below. Oh, no, to the right.
more.
Yeah, hide floating in control. No, yeah,
This one?
yeah, there you go. So if someone else comes, it'll pop off.
Okay, cool.
That's how I know people. It's pretty sad, but it's a CUNY account, so.
Yeah. Um, so constructors is a special method that's typically used to initialize objects. They run automatically when an object is created, and it's typically the same name as a class. And I have an example of an constructor here. With the class would be user and the constructor would be the user. So it might be tempting to put a lot of your code in the constructor because it's very it might seem like it's going to be easier because it runs automatically. It runs on startup, which make it seem like it'd be easier and kind of tempting. Um, it can also seem like a very good way to keep everything in one place, to keep it very organized, to keep all of your variables and everything you need for your code in one place, and that place would be the constructor. As well as it might just make it, for some people, it might just look cleaner to them, just because once again, the code, every part of their code is one place. You can initialize, might be initializing variables, loading data, configuring the object all in one place. It might seem very tempting, and it might seem very easy for someone to do. However,
Also, like, I think that was your first point, is that it has to run.
yeah.
So you can't forget to call
Yeah, it has to run. It runs automatically on setup, so
it.
you
You
can't.
have
Yeah,
no choice, yeah.
yeah,
That's why people wherever they do
yeah,
something, they're not supposed to.
yeah.
Okay, the problem.
That's
Now
fine.
we're
No
getting
problem.
into this. Okay.
So this does too much, which violates a simple responsibility principle, which is the idea that constructors should only initiate objects, and not perform any complex tasks like loading files, making API calls, and or anything that's too complicated. It also makes it a lot harder to unit test because everything is automatically running at the same time. It makes it very hard to individually debug your code or to kind of test to see what functions are not working because everything is going into the constructor makes unit testing very incredibly difficult. It also um can affect error handling. So once again, when you're debugging, constructors typically are not the best for handling errors. So if something
There's a specific reason why. Because what's the return type of constructor?
constructor concern type is always null.
What?
No?
Is none.
None. Yeah.
Is there no,
Yeah.
I mean, it always, I'm sorry, it always returns the object.
Yeah.
That's the only thing it returns.
Yeah.
So, yeah, so that's why it's an possible test, because it's always,
Yeah, it's always gonna return the object.
yeah,
Or
okay.
in
same
assessments.
thing. Right. Yeah.
Thank you for that.
Yeah,
Um,
okay.
Sorry, I lost my train of thought for a second. But yeah, adding to your point, debugging becomes hard because of all of those reasons. It also reduces flexibility because you might want to create an object without immediately running all of the logistics. You might want to take some away, use some, take some away, use some for later. And with a very heavily loaded constructor, it's very hard to do so. If you have all of your code in the constructor, it's going to be a lot harder to customize each object if needed to be later down on the road. And it also does create slower object creation because if constructors are doing a lot of operation, it's going to make the creation of the object a lot slower and affect efficiency. Here I have an example of what not to do. And here I have a picture of a much better approach. And this is a lot better because as you can see, the constructor is separate and then there's separate functions outside of the constructor. So the constructor is not being loaded with too much information. This keeps the constructor simple, which is ideal. It uses separate methods for different logics, which aids in readability and also makes testing a lot easier. So key takeaways is that methods should be for complex operations, not for constructors. Constructors should be simple. Avoiding heavy logic inside them is key for simplicity reasons, also testing reasons, and also by not loading your constructors with too much functionality and things like that, and improve flexibility and design.
Thank you.
Thank you.
I think you're the best person who's presented this topic.
Thank you.
Some people misunderstand it, like I say, put code, they think I mean, I forgot, they misread it and they give it, oh, they don't even, they're wondering why you have a constructor. You understood even some, they don't even understand the topic. Yeah, thank you. Yeah, where I work, unfortunately, a lot of people, they actually do that. They always put in the constructor because they violate this. Well, it's because where I work, we don't have a lot of the stuff never had unit tests, so there's no heavy testing going on. So yeah, it's really not good. But yeah, but that's but it's like you said, it's easy. It's convenient because you know that whenever you create an object, this code will be executed, right? So yeah, okay. So yeah, in fact, we're going to be writing testable code. That's one of the important things they say is not to put like a lot of methods in the constructor because then you can't test. It's hard to test it. Or code, yeah, no, not the law code. Okay. I'm sorry, you had a question? You had a question or? No. Okay. 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 So last week we were, okay. By the way, I'm just, I'm going to start grading the, I mean, not grading, but put entering the grades tomorrow for the project presentations. Okay, so there's some people who missed it, and I'll speak to them after this class. Okay, if you're on Zoom, or you can email me and we'll talk about it. I was just like too, overwhelmed on Tuesday to speak about it. Um, Okay, so let's start again. So, listen, what's our schedule like? Uh, the schedule is um, let's see, how many more classes do we have? Uh, so let's see. We have okay, so we have today to one, two, three, four. Oh, five classes. Okay, we got five classes left. Okay, that's great. Okay, so. Okay, so first thing I want to do is start with the architecture. So, um, okay, so, um, okay, now architectural patterns are different than than this is I'm going to do like a quick review what we did last week. Um, okay, so it was last Thursday, yeah. So so basically, the idea is that we have design patterns, and that's like very low level, and then we have architectural patterns, which are higher levels, which is basically like how the code is broken up, meaning that um, like we are like from a high level view, how is the code broken up? So to give an idea of what I was speaking about, what I mean is we spoke about the three-tier architecture pattern, which is one that I've seen a lot. And basically, the idea is you have a presentation layer, application layer, and a database layer. And the idea is that the presentation layer is the part that you basically when you any program that you use, you're really looking at you can't see a program right running inside the CPU. What do you see? You see the presentation layer, right? That's what you see. That's what we call the program. But it's not what you see is not the program. I mean, what you see is a what the program is displaying to you, right? The display, but the actual program you can't see, right? And that would be the application layer below it, right? So when I click well, if it's designed this way, right? In other words, some programs, they don't have these different layers, and it'll just be mushed together, everything, right? So, but a common way to do it is to divide the application into different layers. So instead of having one big layer, one big, module with everything inside of it, calling everything, right? And it's very confusing to understand what's going on is you would have like at least three modules. You would have like one called, display, maybe, something called business logic, and another one called database, or where I work, we actually call it the database we call persistence because it's a fancy way of saying saving data, right? So we call it we have a module called persistence. Um, and then for application layer, um, we don't really have there, just a bunch of modules. And then for the presentation layer, um, well, the language we use, C sharp, the presentation files are in special, um, um, they're called dot designer. So there are special files which you could which are generated automatically when you know when here, like I'll show you real quick. So you'll see what I mean. So in Visual Studio, let's see if this runs. I'll show you like there's a layer, there's a presentation layer, but the way they do it is, I'll show you real quick. I think Java, like for example, when we do Java, we don't really have a presentation layer. All we have is, printfs, right? I don't even know. Do you have anybody ever work with Java with a presentation layer? Like I've never done it. Yeah, all I've done is print statements. Yeah, but in C sharp I have. So uh, whatever. Okay, this is okay. So over here, for example. The way that Microsoft does it is they do it like this. So they have what they call a designer where you could see what you're drawing, right? You could see the screen and what they do is um, I don't know why it's taking so long to load it. Oh, it's a simple program, isn't it? It should not be take so long. Uh, wow. Come on. It's really, there's nothing on the screen really. It's just a I get, oh, here. So basically all we have here is a button, right? And you could move it around, right? And as you move it around, the, it, what it's doing is behind the scenes, it's writing code over here. So it's actually, changing these numbers automatically. So that's how they do it. So what they do is um, they have you have a screen, and then which you could like people who don't know programming could drag things and put them, and then what they do is the way they save it is they actually convert it to C sharp code. Okay, so it tells you at the beginning, it says, um, do not modify the contents of this method with the code editor. No, they tell you don't touch it because it's generated code, and if you mess around with it, then it's going to get messed up, right? So, but I do it all the time though. I mean, but they tell you, not to do it. So basically, this file over here, this is a presentation layer because this is what's designing the screen, right? So this could be done by anybody who knows how to drag things around and knows how to right click and set the properties, right? You could change the colors, you could change the text. There are all these things you could change. And so that could be written by, this is a presentation layer. Over here is this is the business logic, because this receives the event from the other layer, right? So when the button is clicked, then this code will be executed, right? So this would be the business logic layer, right? And then if I had another file, that would be like another module. So for example, where I work, we would have, let's say, another module called, I would call something like add new project, and we call this, come on, we call this let's say a uh, library project, a class library in C sharp, and we'd call this persistence. Okay, so, and then we maybe have another project called, right, so then we have something, so this project would be over here, persistence. And then we would maybe have probably, if it's a big program, you might have another project called, um, which would be another library or class library, which would be called Business Logic, like something like this. And then you would separate the code. It would be more, obviously, if it's a bigger program, you'd have more than just, yeah, so you have, so here you would have three projects. So you would divide, so at a big company or a big project, you would have at least these three layers, right? This would be the presentation, like Form 1, and then Form 1 wouldn't really do anything except call the logic over here, and then the logic wouldn't, would decide what to do. And it would also, if it has to save data, it would call the persistence layer, which, okay, again, persistence means like to save it. So for example, this would have all the information about the different tables and how to save data to the tables. And if you have tables, if you're saving it to a file, right? So for example, in Microsoft Word, right? So we're looking at is a presentation layer, right? If I click something, it's probably going to call the business layer, the business logic layer. And then if it saves it, it's going to call another layer, which is going to save it to my file, right? So it has the same structure, just instead of a database, the persistence is not saving it to a database, it's saving it to a file, right? That's how, right? But theoretically, it could save it to the cloud, right? Theoretically, it could save it to a database, right? So, um, yeah, I don't know why they don't do that. Never, yeah, that would be a nice option, save it to a database. Um, okay. Anyhow, may, so, and what would be the benefits of saving to database? I'm not sure. Maybe we keep different versions of the same file. Like, I know, like I used to work a long time ago, and we had a operating system where if you change the file, it would save the last three versions of that file. So if you accidentally messed up something, you could always go back. So like if you save this to a file, I think you might be able to go back one version, but if you really want to go back more than that, if you could save it to a database, that would be cool because then you would have in a database, every time you made a change, you would be able to go back to that. So that would be interesting. I think Dropbox might have that feature. Have you ever used Dropbox? I think they have that feature that you could go back 30 days in history. Well, definitely if you delete a file, you could do that. Like if you delete a file, it saves it on Dropbox for 30 days because I've accidentally deleted stuff and and I was able to restore it from Dropbox. So so I like that. That's a nice feature. So um yeah. And also in Git, you heard of Git, right? In Git, you never lose anything. Even if you delete it, it's always there. Right. So um I've never tried to restore it, but there is a way of doing it. Right? Maybe if you use ChatGPT, it'll tell you what commands to issue to get back a project or something. So um, anyhow, does anybody here use ChatGPT for like coding and stuff like that, or Claude or Cursor?
It's all
Uh-huh. Yeah,
pretty important.
yeah.
What's feeding the API limit?
It's what?
It's have a API token limit.
Okay, yeah. You mean for 24 hours you only have
It's
this?
like 8 hours a time.
Oh, per 8 hours? Uh-huh. Yeah, so at work, they pay for it. So, but I get very late. Like I have to do all the stupid things, like instead of looking for a file, right-clicking on it and searching for, I say, hey, Claude, just add this to the project. And I don't know how much money it costs, Claude to do that, so I'm not paying for it, but I get lazy.
Says if you want to say hello to the cloud, it's taking like 300 tokens to,
Really?
yeah,
Wow.
so that's probably a big
I
problem.
wonder how much it costs. I don't, yeah, someone said that because we started using it at work, it costs like $150 a day for our company that we're spending on it. Yeah, so I hope, I mean, it is faster. I mean, the way I use it more like to do stupid things like, you know what I mean?
But Google gives some new companies free tokens, like
Oh, yeah.
50K of the token to free
Uh-huh.
to use.
Yeah, I don't know how this I don't know what we're doing at work, but it's I have ChatGPT also. They tell us to use Claude because it's integrated with Visual Studio, so it works. I don't think does ChatGPT
No,
work? No,
only cloud can.
only Claude. Oh, but anyhow, but like today I asked what it is. I changed a proc. I'm sorry, I converted a SQL to code, and I ran the same thing twice, and then I wanted to compare it, and Claude had a very difficult time to compare. You know, like I put into a spreadsheet, like sheet one and sheet two. I said compare sheet one and sheet two, and like it took a very long time to like it didn't understand like I mean, whatever. It told me that like there was differences, and the only differences was like there was one of them had a space, and like I really thought, oh, I messed up. I was looking, and the only difference was there was this extra space at the end. For one of them had like the word had an extra space. It really, or sometimes they had some of they had a space, and some of them didn't have any space. Like that was the only difference. So like, yeah, it wasn't the real difference. So, but then I used ChatGPT and it went like that. Yeah, so the ChatGPT right away, it was like much, you know, it it actually generated a spreadsheet showing the differences. So you can actually see, like I said, well, first it just showed me the columns, which is kind of weird. Then I said, show me the values that are different. And it showed me, and I see that there's no difference really. So, so yeah, so, so stuff like comparing data, like, ChatGPT but Claude seemed to take a long time. But ChatGPT, it just, I uploaded it and right away gave me an answer, give me whatever, a nice spreadsheet, could look at the values, compare them. And, yeah, and meanwhile, Claude was printing out a file. Um, each row, it gave like a whole, probably waste, but
Always the tokens.
yeah, it's probably wasting all those tokens. And then every time Claude does something, it says, "Oh, here's a summary of what I did." Like, yeah. So I think they purposely do that to waste tokens. Yeah.
Yeah, man.
So to use up tokens. Yeah, I'm pretty sure because like I only asked for a summary. Yeah, and but yeah. So it's just interesting though. But it really doesn't remember. Like I told it to do something, like it did things weird, like really weird. And actually, the thing that Claude generated for me, even though it works, it's very slow. And I'm just like don't have the head to, yeah. Whereas right now, I just like left it alone because I'm burnt out. Uh, but I have to figure out why it's so slow. I am. That's my experience with, but basically the bottom line is you have to know how to code because all these tools are going to do something wrong and you have to teach it what to do. So you have to know, and a lot of times, like, if you can't like just say, create a program for me because it'll just create junk, or very inefficient. Like for me, I even got it after I got it working. It still it's still very slow. I still have to fix it. So um, it's much slower than it's like 10 times slower than the thing it was supposed to replace. So So right now, so after whatever, so so you have to train it. Say when, don't do it this way, do it another way, and then it actually sort of understands. Like you could give it rules, but it's like sort of like a worker, like an employee. I'm supposed to be the manager and supposed to tell it how to do things. Yeah, so you have to train it. You have to train the employee. That's basically what I've seen. My son told me like it creates things and it just like not only did it create like hallucinate something, but it made up the source also. Like so, like he asked you, like you could ask it like a ChatGPT, like why did you arrive at that conclusion? So it created a fake source. It didn't exist. Yeah, it's crazy. Okay, I've never had that. I mean, I've actually had that with Claude. I've had where it created a property that doesn't exist. Like it'll just say it created some property, and then I tried it looked good, and then I tried compiling it. It didn't exist. Yeah, so you have to know a little bit. You still have to know how to program. It's not like a replacement, but it does the stupid things like, like things that are like grunt work, like moving files around, or I could say like take this method and put it together with this other method there. So it'll automatically do that. Uh, and one time today I changed like what it generated, and then it said, "Oh, it looks like you changed it." You and then it said, "Oh, but there's a bug," and it really was a bug. It really noticed that I had a bug.
And then
It said what?
that the call fix it.
And it fixed it, yeah. And then it put in some other code that it was extra, yeah. So, but yeah, it actually found a bug. Like I changed the code. It generated like 20 lines, and then I reduced it to like 3 lines. And I don't even know if it would have worked the way that it did it, but I just thought it was crazy. And then it saw what I did, and then it said, "Oh, you forgot one of this," and then it threw back in some more junk, but also fixed the problem. Yeah, so it was a pretty big bug also. So it was pretty. I thought that was cool. Yeah, it actually looked at what I did and compared it to what it was supposed to do, and then yeah, that was cool. So. Um, okay, so anyhow, so what are the benefits of using layers? So, it might sound familiar, right? Monica from last week. So one thing is it allows people with different skills to do different things. So, for example, over here, we could have the presentation layer, like usually nowadays you have like graphic artists who do like you don't have program like you any like I'm sure what we're looking at in Microsoft Word, it was done by a graphic artist, right? They had somebody and they probably focus groups, and to see what's the best design, you know. Um, and this is what they came up with. Um, and because there's a lot of considerations, right? So, for example, it has to be able to be work with like people who are colorblind, and some people they need bigger fonts, right? So maybe it's a bit bigger resolution. So you have to have somebody who's good with that. So that would be the presentation layer, right? So that would be like one skill. And then for the business layer, the business logic or application layer, that would be people who understand what the program's how it works, right? That would be like you know, most of the people on the project would be in that middle layer. And then the database layer is someone who's good at saving data, so it's easy, it's quick, right? Because like if you manage like Amazon or let's say even Walmart, I don't know if all the stores are connected, but if they are connected, so they have a huge amount of sales per second, right? So how do they, keep track of all that information? Even in one store, there's a lot of data, right? So you need somebody in charge of designing it so that it captures all the information quickly without, checkout being slow, right? You want it to be quick. So all these things, so that would also be like a different specialization, right? Somebody who knows, um, you know, um, databases, like, knows the database design, especially nowadays, they have all these different new types of databases. So, and you have, right, okay. So, okay, number two, um, that if we break a layer, right, we, in other words, in other words, when one of the, when we have layers, right? In general, they can affect the other layers. For example, the application layer could write bad data to the database layer, and it could give wrong information to the presentation layer, right? But if you look at the way it's designed, the top layer, it can only, if you change the top layer, it really, oh, actually, it could affect it. Yeah. Actually, that's really wrong. Yeah, so it's actually, they can affect the layers next to it. Um, and that's really wrong. Okay. It depends what you mean by, you don't really break the layer, but you could pass the bad data and you can mess up how that works. Um, yeah, I want to be more clear. Uh, See, you can't really break another layer, but you could, oh, that's cool. Okay. Um, you can't really break it, but you could give it bad data. Let me just get rid of that idea. It's just too complicated. Um, okay, now this is important, that if you have the layers done correctly, so then, if they're really separate, right? Then, for example, let's say I want let's say Microsoft Word is really written well. So then, um, all I have to do, maybe I could take Microsoft Word and put it on, let's say, a Linux computer, and only thing I would have to change would be, let's say, the presentation layer, or I could put it on a smartphone and it would run, right? And all I would need is changing how it looks, the screen part, So that might be or I could change the bottom layer, right? I could change, let's say my boss says, let's write it to a date. Like I said, we'll give you an example. Let's, instead of writing Microsoft Word to a file, save it to the cloud, right? I could change this layer and make it, or save to both, right? Automatically, or whatever, wherever else I want to put it. No, or so I could, so if it's done well, it's easy just to swap one layer and not destroy all the code, right? Because each layer is separate from the other, right? So all the presentation layer logic would be in one file, and then, or one module, and then the application layer and the database layer, they're all separate things. So I could change different parts without affecting the other one. That's the idea uh, of having these layers. Um, okay, now I just threw this in over here, but I guess I want to make sure it gets covered, is what are issues with using the web, like a web page, right? So one big issue, which it's which everybody knows about, is the security, right? That um, because our program is, every website could be accessed from anywhere, right? So security is anywhere in the world. So you have 6 billion potential hackers, right? So anybody could try to crash your website, or, somebody somewhere in some remote island somewhere could try to crash your server, right? So, either it's you against the world. So you're on your own. So that's a little bit scary. Another issue is that you don't have control over the presentation, meaning that you have to rely, for example, like when I go over here, what am I looking at? I'm looking at my browser, and my browser is displaying to me data from the Google Drive server, right? So the architecture is you have a server, right? Google Drive server, and then you have this browser, and this browser is a Chrome browser, and so it happens to be in this case it's written by the same people, same company, but it could be I could be using Edge as my browser, right, and looking at Google Drive. Right, so they have to be, they don't have control over how it's presented, right? So basically you're a very, HTML is a very, like it's very limited, what it could do, right? So, so that's another issue, with web. It's different than when you write a program for a desktop, okay? Um, Another thing you have to worry about is you could tell me if I leave something out, okay? Please, you could add or subtract if, it doesn't make sense what I'm saying. But another thing is that let's say you go on the subway, right? So you have sometimes, or you go on an airplane, sometimes you'll have internet, sometimes you won't have internet. So you have to when you write a program, you can't assume that when you write a website, you can't assume that the person has a great internet speed, et cetera, right? Because you don't know where they're going to be, right? So, so um, therefore you have to do something. Usually you do like JavaScript or something to do, they can't, if you put all the logic on the server, which would make sense for a desktop application, but it doesn't make sense for a web application because then every time you click a button, there's like what's called a round trip. So it sends a request to the web server and the web server replies, right? So so basically you have to add JavaScript mostly or to speed things up, right? Um, or to take the load off of the server, right? Because right, you don't want to have everything on the server. Um, Also, to make it interesting, it takes work, right? Because it's just plain HTML doesn't is pretty boring. Um, Number five is another thing, is that this is where you've heard of cookies, right? Right. So what is the role of cookies? So like for example, if I go to Amazon, my cart, when I add things to my cart, and then I go away, let's say, they'll remember what's in my cart. How does it do that? Well, there's different ways to do it, but one way to do it is through cookies, right? So basically, it stores my shopping cart on my machine in a file, and then it automatically knows, right? I don't understand the whole how everything works, but that's basically the idea of because what happens is that when every time you go to, um, let's say I go to Google Drive, right? So it every time I click something, it's a new request to the server. So it doesn't remember what I did previously, right? So it doesn't have any context of what's going on, right? So when you use a cookie, that gives it a way of like keeping context of what's going on. Like a cookie could like keep track of what page you're up to, where you are. So when you go the next time to the web server, it knows, oh yeah, I already entered this information, up to this step already, right? So you don't have to start over again every time you go to a website. Um, and then they expire and stuff like that. So, um, okay. And then, okay, so that's a challenge, right? To remember the state of, uh, um, you have to somehow, a web server has to be able to know when somebody connects to it, oh, did they already fill out, let's say, they already put stuff in their cart, right? So you somehow has to keep track of that, right? Because otherwise it won't be very useful, right? Because, when you go from, let's say the person, goes from Amazon and goes to Walmart, comes back to Amazon, he has to remember what's in your cart, right? And how does it do that? So it has to somehow store the information somewhere. And another thing is, this is a very interesting problem, is that let's say you have, in other words, one of the beautiful things about a web server is you could have multiple web servers for the same site. So for example, Google has a search engine, right? So you could have, let's say I'm in Japan, they could have a server, let's say in Asia, I guess, or and then you have maybe from North America, maybe another server in South America, so that when you connect to their server, you get the same information, but it's actually different servers, right? So you don't have like one server in some place handling every single Google request from all over the world, right? That would be, way too much load, right? So with web servers, you could have you could have different web servers with the same information, or connected all over the world, right? Or even in one place, right? Because you don't want to have one machine you can't even have one machine handling the same load, right? That's why you have like these data centers, they're using up all the electricity, right? Because they can't handle all the load. So the problem is that it's like for, let's say, a Google search, it makes sense. You have different websites, web servers, so each one has a complete copy of each other, right? And then maybe say they get updated, let's say once a day or whatever, right? But let's say you have something like Amazon, where there's only like, let's say they're selling 30 toothbrushes, or let's say they have 300 toothbrushes, and and let's say 20 people are buying the same toothbrush at the same time. So they have to somehow, the people might be on, one person might be buying it from using a web server in, let's say, Indiana, while somebody might be using a web server in New York and one in Chicago. So somehow they all have to, they can't be totally separate because they're all selling the same item, right? So it only has 300 of them. So it has to keep track how many are being sold. So, and how many this person put into their cart, stuff like that. Um, so that's an interesting problem, is how do you have, so usually you have, so even though you might have multiple web servers, but you have to have one point where you keep track of everything. So how do you make it fast? Right? How do you make that one? So if you're using SQL Server, a SQL server, right? That is very slow. Why? Because it does, every time it does an update, it locks the table from everybody else, right? Because otherwise the data would be messed up. So it has to lock, and but if you have, let's say, a lot of people buying at the same time, how do you do that? Right? You can't lock the table, and then what's going to happen? Other people, they're trying to buy things, and they're just waiting there while, you know, other people buy the same thing, or you only have, you can have multiple items in one table. So it's a big issue with websites, is how to handle um, uh, this load, because this can't be divided up, right? This has to be kept. You have to have only one location. Has to keep track of everything, right? For all the sites. So that's, I think, where part of this is part of the reason why if you heard of NoSQL, that's why it's becoming popular, is because of the web servers. You can have multiple web servers, but you have to also have a database that's quick. So SQL locks tables. NoSQL works a little bit different, right? So it's like MongoDB, and so you could split things up. Um, um, but so basically that's those are the issues for websites. I don't know if you could think of anything else, but okay. So but anyhow, that was just like a side thing about web application issues. Um, then now going back to this our chapter. So if you remember, okay, let's swivel back to our chapter. We're talking about architecture. So this is from the book that if you think about, in other words, what determines which architecture you're going to use. So we know that there are different types of requirements. There's functional and non-functional, right? So you would think, at least I would think, that based on what we needed to do, that determines the architecture, right? But actually, the non-functional requirements, because remember, non-functionals are like they're behind the scene, but they're very important. They affect the whole program. So those requirements usually determine the architecture. So, for example, in the book they give a bunch of examples. So for example, let's say performance, right? That's a non-functional requirement, right? That it's not one individual thing, but like let's say you have Tesla, it has to make a decision right away whether to, turn or stop or, whatever, right? It has to, if it's something right in front of it, it detects a person, an object in front of it, it has to slam on the brakes, right? So you need speed, you need performance, right? So so if you have that, then you can't use a client server architecture, right? So a Tesla car can't be speaking to the internet while it's driving to decide what to do, right? It'd be a lot cheaper for Tesla, right, if they could do it, but it'd be dangerous for the driver, right? Because they're driving in a tunnel, no internet, and they won't know what to do. So you need the logic. You can't have client server architecture, right? You have to have all the logic on that on that car, right? It doesn't mean he has to be like in the same module, but in the same, but it has to be able to, it can't like take time to make a decision, right? So generally the architecture is going to be like everything is together, right? Because it has to be able to decide right away. And opposite of that would be like Alexa. How does Alexa work? Well, I don't think you should own it, but but how does it work? It actually, well, actually, when I drive it, Google listens to you also, right? So it's listening for the words "Hey Google," right? But if it's listening for "Hey Google," it means it's listening to everything else you say also, right? Right. So how does Alexa work? Well, it really is very cheap device. That's why Amazon get how they charge you, like $30, right? Because all it does is it recognizes the words when you say "Hey Alexa" or "Alexa," I don't know what you say, but whatever you say, and then the rest of after the words "Hey Alexa," it sends to Amazon. It actually just captures your speech, it sends it to Amazon, and then Amazon tells Alexa what to do. So basically, if you look at the architecture, it is client server. And the reason why they could do it is because they're not using Alexa to drive a car, right? You're buying something or turning on the light. So even if it takes a couple seconds for the light to turn on or play a certain song, that's okay, right? No one's going to die, right? So it's not life critical. Right? You wouldn't put like you wouldn't have Alexa control a um what? Yeah, it went a medical device, right? Um, yeah. So if you look over here, you'll see that they have a diagram of Alexa. And you'll see that it's actually it actually has client server architecture. So um, where's the picture? Here it is. So you see it works like this. You say uh, can get it bigger. Okay, well, this is it. Could you see that? So it starts over here. It says, Alexa, ask, I can't read it, Digi, whatever, whatever. So you enter a command, and then this goes to the Echo, Echo, whatever, the, a similar device. And then that looks for it converts the return text. Oh, I'm sorry, it sends a voice stream to um, whatever Amazon. Amazon decides what to do, and then you see an orange or yellow, the response that tells the device what to do. Right. So actually Alexa the device doesn't really have a lot of, it doesn't like even, it only has to understand two words, hey Alexa, right? And that's all and the rest it just sends to Amazon. Okay. Yeah. So there's been a court case, I think, where they solved a murder using Alexa, like, because it really records more than the words. Hey, Alexa, like it was like recorded, like it sent it over to the server. And also, I heard they had like these programmers in some country, um, like Amazon hired these people uh, to make sure that Hey Alexa gets understood, and like they would play tapes of people. So they actually recorded the tapes of people saying, "Hey Alexa, do this and this," and then they would play it, and they would see why it didn't work or it did work. Right. But actually they actually were recording people's, things they were saying, which is pretty scary, right? So to me, it's scary. So, but anyhow, so this could be slow, right? So this could use client server, right? So the all the way to the right, you have Amazon web server, and then you just have this simple device over there. Okay. Um, okay, so that would be an example. Another example, let's talk about security, right? So let's think about Queens College. Where's the security? Is there any guard outside the building? Well, I just saw a sign that there was a camera somewhere here. I don't know if I believe it, but uh, but it's about time they had the cameras in this, yeah. But um, but where's the security in Queens College? Well, the answer is it's around the college, right? So it turns out that that's a common architecture for most programs is that you put the security as a gateway to like you authorize people to get to right you authenticate you authorize people to get into your website right? And once they're in, they could do usually whatever they do. But to get in, so basically the idea is you build a wall around your program, just like so just like you have an outer layer or the top layer of security, and then you have to go through that layer in order to get access to the rest of the program, right? So that would be that architecture, right? So um, they would have a security layer, you can't do anything until you get through security, right? Like Queens College, right? You can't, uh, well, at least, well, now there is no security. This gate doesn't have any security, but yeah, during COVID, it was really good. I was really, I remember it was like they used to check IDs and all that, made sure you had a COVID test, but like it was, but then now they're just, relapsed in their security. Yeah. I used to have people walk into my classroom who would just walk in and say, I'm an alumni, and they would try selling, like, they would sell, they would just walk in and they would start selling, like, they would make it sound like they were part of the college or something. And they were selling, like, or giving out tickets to a bar or something. I forgot, or a club for a club. And like, and I said, if you don't leave, I'm taking a picture of you. But like, random people just walked in, and they stopped doing it. Yeah, I don't. And I remember I went to the guy. I said, well, "How could you just let people walk in?" Yeah, So it was very funny. Like the first time it happened, I didn't realize what was going on. Then I realized that they're just, random people selling stuff. Um, okay. Okay. Um, okay. This is a little bit different than security is safety. Safety means that okay, we have time to finish this up. So, safety is, um, basically that, um, we, in other words, security is we want our site private. Safety is we want to make sure it does the correct thing, right? The application, let's say, doesn't do something harmful, like, you're driving a Tesla, you don't want it to all of a sudden speed up, right? For no reason, right? So that would be safety. So if that's the requirement, so then, it should be designed so it should be, uh, designed so it's easy to spot mistakes that could harm people. Meaning that, I don't know why it doesn't, where the rest of it is. Um, in general, um, the safety logic, safe safety logic should be easy to analyze. Uh, Usually by being in one location. It's like in one module. If you have safety is a big concern, you usually don't want all the logic spread out all over the program because then it's hard to analyze it, right? You want it easy to be able to see, oh, what's going on if what's causing this to, with the interaction. Okay. So that would be the architecture you would use. You'd use more like all the safety code would be together in one spot. So it's easy to analyze. Okay. And the maintainability is the ability to, which is part of the goal of this class, is to make sure that code is easy to fix. And then when you change code, when code is modified, it doesn't break the program, right? So in general, the best way to do that is, besides all the other object-oriented principles, but one of the most important ones is the, idea of having things that are a lot of things, but they're all, in other words, it's better to have a lot of things that don't do very much than to have like a few things that do a lot each, right? So with programming, the more, like I'm thinking, like where I work, like most code does like maybe 2 or 3 lines, maybe 4 or 5 lines, but not no more. Like I remember when I first started working, you would have, let's say, some modules with like 200 lines of code. But now, what I see is that each method, you have methods that would have like 200 lines of code. Now, you never see that. If you do see it, it's really bad because it's really hard to debug that. So, I actually have seen that only like once, like somebody wrote this huge method, which was like, it was crazy to, you know, it was, like, it was crazy to modify that because it was just so intertwined. Like it was all these, it was like a whole big stack of steps that relied on each other. And that was like, the person was trying to make it very compact, the code, but it was very hard to, to see what would happen if you make a change. So, so what's much better is if you don't have that, you have like just like 3 or 4 lines of code, and then when you make a change, you could see what's going on, right? You split it up, right? You don't have, of course, there's always, you don't make too many, you could always go crazy and, have, too many, split up, but the idea is to split it up reasonably so that somebody making a change will be pretty confident that, what the change is going to do, right? It's not going to, destroy something by accident. Okay, so here's a bunch of patterns. So where we spoke about the three-layer pattern, but there's also, you could have even more layers, right? Okay. And okay, so this would be example, you could have as many layers as you want, right? So like for example, where I work, besides the three tiers, we have another within each tier we have like different tiers. So like one is like just the table level, one is the objects that the table that the tables are the row data is loaded into, and then there's utility classes, stuff like that. That would be the lower level. So there's a bunch of you could have a bunch of layers, right? Um, and the idea is that the ones at the bottom, right, they're basically independent of the ones above them, right? You don't have like a circular dependency where things on the bottom are calling things on top and things at the bottom are jumping layers, right? The idea is to have each layer be independent of the other one. It's very difficult sometimes, but it's worth it because then when you change things, you know that you didn't break another layer. Okay, then we spoke about client server architecture, right, which is basically every website, right? You have a server, and besides the website, it's also databases or email, right? That's nearly always a client server, right? Because you have the Outlook or uh, um, a database, a banking server, right? Or basically anything over the web or basically databases, right? That's also one database and there's lots of different clients who are asking it for information. Then there's something called the pipe filter pattern or architecture pattern where you have, if you're familiar with Unix, so the idea is you could have like the output of one program, it goes into another program, which then, it's the output of one program is the input of another program. So like in Unix, you could like do a directory command, then you could send it to a sort, a program, and then you could send the output of the sort to something else that will, let's say, save it to a file, right? So you could, so the idea is that you have these, what the architecture is that you have separate programs which are capable of creating a specific output which can be read by another another program. In the case of Unix, you could actually move the programs around, right? You could sort and then do so basically that's why it has these. The pipe is basically the data goes between, and then the filter is really like the different programs. Okay, it's really called pipe filter based on because of Unix, but it's not really filters. It's really just programs, right? Like for example would be nowadays would be let's say C++. So first you have, I don't know if you remember, you ever did C++? You have a pre-compiler, right, which takes all the headers, and then that's one program, right? You could buy different ones. You don't have to use, the same. Usually nowadays it all comes together, but it used to be you could buy separate ones. Then you have the compiler, which puts all the code into object files, if you remember, which is binary code. They have the linker, which puts everything into one program. So you could actually, when I was doing C++, I remember there are different companies you could buy to do different parts of it, right? So you could get by like a special linker, which is or a compiler, which is more it basically made the code run faster. Okay, and then there's peer-to-peer, which is like the best example would be, let's say Bitcoin, which is basically the idea is that that my program, my computer, or my is basically both a client and it's a server, which is kind of crazy because why would you want other people look at your computer? Right? I don't get that. So, but I don't, but that's what I read about. But so Bitcoin is example of you have two computers where each one is both a client and a server, right? It used to be something else called I forgot, a file sharing, right, which is illegal now. But basically, it used to be people used to download movies, and each person, let's say, download half a movie on their computer, and someone else would download the other half or different movies, and then you would watch it by, you know, by you would be like each person who was watching a movie would be, reading someone else's computer. They were getting it from them. So, um, yeah, but that became illegal, so it's not done anymore. It's also a little bit crazy. You don't want another person using your computer as a server, right? Um, because okay. Last thing we're going to do is MVC. And MVC is called Model View Controller, and this is a pattern which is nearly the same as a three-tier. So the three-tier is for like a desktop application. MVC is what's used on the web server itself. So basically, you have three parts. The M is the model, the V is the view, and the C is the controller. So basically, the idea is that when the person clicks something on their web page, it sends a request to the controller, a layer gets it, and then it asks the model what to do. So this would be like the business layer. I don't know why they called it model. And then uh, and this is actually both the logic and the database would be the model. And then basically it would send then and then there would be a view layer, which sort of like is the same as a presentation layer on three-tier, which will send the response back to the device because different devices get it formatted differently. So the view will be in charge of deciding how to display the response. And this is another example. So you have the controller. Again, they're basically the same idea that the controller gets the idea is that the controller gets the user action, and then it passes the model, and then the model sends it back to the controller, and sends it back to the view. I like this one a little bit better. It makes more sense. Okay, but it used to be more common, this model. It's basically Microsoft basically like built it into Visual Studio, but I don't know how popular it still is. But this is a architecture. Okay, it's the same idea as the three-tier, but it's running on a web server, right? So instead of displaying it on the screen, it's sending a message to the client through the view layer, right? It's telling the client the message, and then the client displays it, right? But it's pretty much the same idea. Okay, so it's also dividing it up, but it's working on the server. Okay, so that pretty much ends. Sorry, I went late, but it pretty much ends our chapter 8. No, chapter 6. Sorry. Okay, and then chapter 7 we're going to skip, and then next Tuesday, if you want, I'll review this one time, and then we'll do chapter 8, which is testing. Okay, so we're doing well. Okay, so so I'll see you on next Tuesday. Okay, have a good weekend. Okay, anybody want to speak about the project presentations or any questions about it? Well, you can send me an email. Okay, because I know two people said they forgot what they missed. Oh, they were in college and they couldn't do it because they got kicked out of the library. Yeah, so uh they closed at 10, the library, really?
Yeah.
Wow. That's a new thing, right? Is that, I'm sorry, it was,
Seven.
oh, oh, I thought it was open later. Okay, well. Anyhow, so I have to get their presentation. Okay, so